All right, continuing on. So graphed our two functions. So our radical function here is f of x. Our linear function here is g of x. And now we want to subtract these two functions. So we're going to start to subtract all of our y values of these two functions. So obviously, if my radical function, a negative x value, not exist, it's not going to, I can't subtract these values either. It still won't exist to my new functions. Not going to exist. So my first value here would be 0 minus 0.5 would be negative 0.5. So when x is 0, or sorry, when x is 1, we're going to have a 0.5 value. So I'm going to put an x there just to show the difference between the two graphs. Subtract these two values, I get 0. So now the graph is going to come at 2. It's going to come up to that point. Subtract these two values is a negative 0.5 again. So now I'm going to come back down at 5. So at 5, you're there. Subtract these, I get a negative 2. So at 10, my graph is going through there, and so on. So if you can visualize this graph, my graph is going to start there, come up. So again, kind of a different looking graph here. It's going to look something like this. State the domain of the graph. So the domain of our graph is starting at 1. Or can equal 1, where x belongs to the reals. So looking at our graph, the range, the highest point it looks like is going to be at 0, and then the graph is decreasing from there. So y is going to be less than or equal to 0. All right, moving on to example number 3. It says sketch graph from a graph. So we're no longer going to use a table of values or an equation. We're just going to give it a set of two graphs. So sketch h of x, which is f plus g, and then we're going to do f minus g of x. So looking at these two functions, if I want to find the sum of these two functions, what I want to do is I want to add all of my y values. So for example, here at negative 4, my y value, and make sure with this sum, it doesn't matter the order in which you add them. In subtraction, it does. So just that. So we want to take f of x, which is this guy, and we're going to add it to g of x. So we're going to take a negative 3 and we're going to add it to a positive 1, which would give me negative 2. So that new point would occur there. Here I'm going to take a negative 2 and I'm going to add 0, which would be negative 2. Here I'm going to take a negative 1 and add a negative 1 because they both have a value of negative 1. I get negative 2. Negative 2 plus 0 again is negative 2. Negative 3 plus 1 is negative 2. So you can start to see what's happening here is when I add them together, negative 5 plus 3 would give me negative 2. All of these values, when I add these two linear functions, I'm just going to get I'm also going to get a linear function, but I'm going to get a straight line, horizontal line going through x equals negative 2. And then I'm going to subtract these values. So be careful here. I want to subtract g of x. So again, let's start here at an x value of negative 4. F of x is negative 3. I want to subtract 1 from that. So negative 3 minus 1 would give me negative 4. Let's go to this point here. Negative 2 minus 0 would give me negative 2, so it's going to go through that point. Let's go to this point here. Negative 2, or sorry, remember I'm taking f of x, so 0 minus a negative 2, 0 minus a negative 2 would give me a positive 2, so that point is going to end up there. Let's go to this point. 3, oh, we might not get it on the graph, so let's go here. 2 minus a negative 4, 2 minus a negative 4 would give me a positive 6, which is way up here. So what we get is we get a linear, again, a linear function. It looks like this. right, and that is how you would subtract two functions. So when you're just given graphs, what you want to do is you want to just take every y value and subtract them until you have a good sense of what the graph is going to look like, and then sketch the graph. Last example, the cost to make t-shirts is $100 for a cheap silk screener, and then $5. The shirts are sold for $25 each. Create a cost function, C of n, to represent the cost of making t-shirts. So the cost function, which would be C of n being the number of shirts, the cost is $100 for the silk screen, $5 per shirt. So 5n plus $100. Okay, and then let's just graph this function. So change the scale here. So this is 25, 50, 75, this is 100. So I have, this is 100, and then each of these is going to represent one shirt. So here's my y-intercept, and then I need a slope of 5. So my slope would be 5 over 1. So for 5 shirts, 1, 2, 3, 4, 1, 2, 3, 4, 5, this will go up, or the rise is 5 and the slope is 1. So this, it could be equivalent to 25 over 5. So if I go over 5, 1, 2, 3, 4, 5, and up 25, which is here, gives me my slope. So because our scales are different, it's going to be a... Alright, so there's our cost function. Now we're going to create a revenue function. So our revenue function, how much we make. Shirts are sold for $25 each, so that's how much we're making, 25n. So sketch this graph now, starting at 0. Up 20, for every $25, we sell one shirt. Up 25, 1. So this is our revenue function. So as you can see, our kind of break-even point is 5 shirts. Create a profit function. So our profit function is the difference between the revenue and the cost. So our profit function is our revenue function, which is 25n, minus the cost, which is 5n plus 100. So if we simplified this, 25n minus 5n would be 20n minus 100. So if we went down, this is, assuming this is at, this is our line, 25, 50, 70, negative 100, and then I'm going up 20, so about there, and over 1. Or if I, at 5, so if our slope is 20 over 1, this would be the same as 100 over 5. So I could go up 100 and over 5. Which on the y-axis would be there. So this is profit function then, which this is sort of makes sense. At what point am I going to start to make money? I'm going to start to make money at after I've sold 5 shirts, which is kind of makes sense when these two graphs cross, is our break-even point, right? So draw each function on the right, analyze the meaning of key locations. So when R and N, when our revenue and cost function intersect at the break-even point, which also represents when the profit function equals 0. So after selling 5 t-shirts, we will begin to make profits. What is the domain of P of n? Well, in order to make profit, right, what is the domain of P of n? Well, we're not going to sell 0 shirts, right? So the domain would have to be n has to be greater than or equal to 1, where we don't want to say n is part of the real numbers because we can't say, we don't sell half a t-shirt, right? So here we want to say n belongs to the natural numbers. All right, and that is adding and subtracting functions today.